Hello, I'm Saif Ahmed and I'm going to integrate this equation using integration by parts. We are going to use the tabular method for this equation because we have the e to the power negative 2x. So first we should choose a u, and it will be x squared according to Liat. We have the exponential and the x squared algebraic, so the u will be x squared and the dv would be e to the power negative 2x dx. Let's make a table. We will keep on getting the derivative of this one and integrating e to the power negative 2x. The derivative of x squared is 2x, and the integration of e to the power negative 2x is negative half e to the power negative 2x. Then again, the derivative of this one will be 2, and the integration of this one will be 1 over 4 e to the power negative 2x. The derivative of this one will be 0, and we stop here, and the integration of this one will be negative 1 over 8 e to the power negative 2x. Now we are going to multiply this by this, and this by this, and this by this, and add them together. But first, we use a positive here, a negative here, and a positive here. So, the integration of x squared times e to the power negative 2x dx will be equal to negative half x squared e to the power negative 2x. Let's write it here, it's better. Negative half x squared times e to the power negative 2x. And then we again will multiply this one by this one, but here we will use a negative. So it will be negative 1 over 2x e to the power negative 2x. Again, we'll multiply this by this, and we are going to get a negative 1 over 4 e to the power negative 2x. And we should always add a constant c. This is the final answer.
For this question, we will solve this example using integration by parts. What is integration by parts? It is a method to find the integral. It has its own formula, which makes it easier to solve. First of all, how does it work? So, first of all, we need to find what it should be u dv, and by using the Liat rule, we can find that x, which is algebraic, is before the trigonometric, which is secant squared x. So the u will be equal to x, and the dv will be equal to secant square x dx, and so du would be equal to dx 1 dx. So because the derivative of u will be 1, and for v we already know that the integration of secant squared is tan x, and we know that the derivative of tan x is secant squared x. So v is equal to tan x. Now we must use the formula of integration by parts, which is uv minus integral of v du. Now we just substitute, so it will be x times tan x minus integration of tan x dx. We know that the integration of tan x dx is equal to negative ln cosine x plus c. So x tan x plus, because minus minus would be plus, ln cosine x plus c. And by using parts we solved this example pretty easily. So parts is a really useful method.
And now again we will discuss the integration by parts. First of all, if we have any integration question or example or anything, we will have two parts in the same integration. We have to see if it's logarithm, inverse, algebra or exponential or trigonometry. Now from this we decide if it is u or dv. The u will be by the distribution of this from the first to the last. The u will come in first, and the dv the second one, or from this from this order. Okay, here we have an example. We have an example here. Integration here again. Integration of x squared e to x dx. Okay, here we can see that is this an algebra and this is an exponential. Here the algebra come before the exponential, so x squared. So x squared, it is u. Okay, and the dv is ex exponential 2x. We will use the Taylor method. We do like this. Here the u, it is x squared, and here negative 2x. Okay, like this. And here we do, and this is derivative like this. Here derivative, here we have 2x, here 2, and here 0, and here we will get negative half the integration of this. Integration here, the integration. Okay, here half e negative 2x, and here we 1/4 e negative 2x, and here 1/8 e negative 2x. Okay, then here we multiply the first one by the second, first by second. Here multiplication, and here plus minus. Okay, now we have the answer. The integration of x squared exponential 2x dx equals to x squared. Here we will have minus half exponential 2x minus 2/4 minus 2/4 here, yes, 2/4 e x e to x, and here then we have a plus here, but here is negative, so we do negative 2/8 e to x. We can simplify this and this by here getting 1/2x e to x, and here also 1/4 e to x. Okay, so the final answer is negative half x squared e to x minus 1 over 2 x e to x, also minus 1 over 4 e to x plus c. And this is the answer, the final answer.
I am going to explain integration by parts today. Integration by parts is a special method where you have two functions that you can simplify. So you can use integration by parts to integrate them. The format of integration by parts is integration of u times dv equals uv minus integration of v du. And this method is also called video method because of v du, to make it easier for yourself. Now we have an example here. Integration of x sine x dx. Now if you will ask, how do you know which one is u, which one is dv? You can use this word or abbreviation LIATE, which stands for logarithmic, inverse trigonometric, algebraic, trigonometric, and exponential. Whichever comes first is the one you choose for u, and the other one is dv. For this case we have x, which is considered algebraic, and sine x, which is trigonometric. Now x algebraic comes first, so you choose u equals x, and dv equals sine x dx. Now we'll get the derivative of u, so du equals 1 times dx, and we'll get the integration, so we can get v is the integration of sine x, which is negative cosine x. Now we'll apply this formula, integration of x sine x dx equals u, this x, times v, which is negative cosine x, minus the integration of v, which is negative cosine x, times du, which is here 1 times dx. Now we can get this negative out, so that negative x cosine x plus the integration of cosine x dx, which equals negative x cosine x plus sine x, which is the integration of cosine x. Now we got the integration of this integral, which contains two functions, x and sine x. Now let's see another example. Integration of x secant squared x dx. Now as you can see here, we have two functions, x and secant squared x. So we apply the word LIATE, x algebraic, secant squared x is trigonometric. So u here equals x, and dv equals secant squared x dx. Now if we get the derivative of u, it will be 1 times dx. And integration of dv, secant squared x has an integration of tan x. Now we'll take the derivative again to make this 0, and we'll take this integration again. It will be negative ln of cosine x, and we can use this as a table. Now we multiply this one with this one. First one positive, then negative this one times this one. So the answer will be x tan x, which is positive because it's the first, minus 1 times negative ln cosine x. So negative and negative will be positive ln cosine x, and don't forget plus c. Now this is a way of the integration by parts which is called the tabular. Let's see another example. So question 11. Now question 15 has this integral, x squared e to the power of negative 2x times dx. Now we will use the same way as we used for the previous example. So u equals x squared, dv equals e to the power of negative 2x. Now we'll take the derivative of this one, it will be 2x, integration of this one, take a table. Now the integration of this e to the power of negative 2x is the derivative of the power. You divide the derivative of the power by e to the power of negative 2x. So the integration of this one will be 1 over negative 2, which is the derivative, e to the power of negative 2x. Now we take the derivative here, 2x, the derivative of it will be 2. Now we will divide by the derivative again. This time negative and negative will be positive. 1 over 2 over 2 is 1 over 4, e to the power of negative 2x. Now the derivative of 2, because it's constant, would be 0. And this would be negative 1 over 8, e to the power of negative 2x. So this one times this one minus this one times this one plus this one times this one. So x squared e to the power of negative 2x, this is over negative 2. Now this one times this one, it should be minus 2x over 4 e to the power of negative 2x, and plus the last one, which is already negative, 2 over 8 e to the power negative x plus c. Now this is the integration of x squared e to the power of negative 2x dx found by integration by parts. Let's see another two examples. Now question 18, given a differential equation of dy over dx, x plus 2 sine x, and also given an initial condition of y of 0 equals 2. Now this differential equation is separable, so the first thing we need to separate d of x and take it there. So dy equals x plus 2 sine x dx. So again we have two functions, x plus 2 and sine x, algebraic and trigonometric. We take the integration of the both these sides. Now integration of dy will be y. This integration will be done by integration by parts, which is y equals x plus 2 and dv equals sine x. So integration and derivative of u is 1 dx, in this case because the constant is 1 for x, and v equals cosine x, negative cosine x actually. Now we apply the formula u times v minus integration of v du. U here is x plus 2 times negative cosine x minus integration of v negative cosine x times du, which is dx. X plus 2 negative cosine x plus integration of cosine x, we get this negative outside, dx integration of cosine is sine x, plus sine x plus c. Now we take this integration up there, negative x plus 2 cosine x plus sine x plus c, and this is the integration of x plus 2 times sine x. Now we can find c given the condition, the initial condition y of 0 is equals to 2. So going back to this equation, y equals all this integrated, this general solution, so we'll find the particular solution. We'll substitute y, 2 equals negative, and x, which is 0 here, plus 2 cosine 0 plus sine 0 plus c, c equals, we get the calculator. Negative 2 minus
will solve this question, which is from the system mod quiz multiple choice, using integration by parts. First of all, it will get here x will be as it is here, and then we will put the integration of secant square x, which is tan x, minus the integral of the derivative of x, which is 1, times the integration of secant square x, secant square x, which is tan x dx. Then the integral of tan x dx is negative ln cosine x. Put this in a bracket, and we put x tan x minus which will become plus, so it will be x tan x plus ln cosine x.
Okay, so we found C4. Now y equals negative x plus 2 cosine x plus sine x plus 4. This is the particular solution. Let's see the last example we have. Example 19. dy over dx equals 2x ln x, and given a condition of y of 1 equals 3. Separate dy from dx. Integrate both sides. Y equals this integration. You have two functions, 2x and ln x dx. Now ln x, losing liate, logarithmic comes first, so u equals ln x, dv equals 2x. Integration of du of u, the derivative of u gives us 1 over x. Integration of dv gives us 2x squared over 2. 2 cancels with 2, so it's x squared. Of course, here's dx. Now this turns to u times v, which is 2x ln x, u times v, no, it's x squared ln x minus integration of v du, which is x squared times 1 over x dx. Now x cancels with one of these x's, so x squared ln x minus the integration of x dx. So the answer is x squared ln x integrating x gives us x to the power of 2 over 2 plus c. Given the condition here, we can substitute 3 equals 1 squared ln of 1 minus 1 squared over 2 plus c. So c equals C equals 3.5. So the particular solution here is y equals x squared ln x minus x squared over 2 plus 3.5. This is the particular solution using integration by parts. Thank you.
Welcome to the second part for the integration by the objective of integration by substitution, where we'll solve question 15, 18, and 19 from the free response system-wide quiz term 2. Question 18 and 19 will be is for both objectives, integration by parts and solving differential equations. So it will be repeated, it will be only solved in this video. So you'll not find it in the solving differential equation video, since it has the same objective. So let's start with question 15, which is find integrals by showing our work. The integration of x squared times e power minus 2x delta x, dx. Integration by parts is separating the u and the dv. For this part, since we have e, if we use the dv and the u, it will last forever. For example, if we use the equation u v minus integration of v du, this equation will be repeated multiple times, which will take a lot of times, and it will get harder over time, since we have the e, where it's integration itself. So instead of this, we will use a trick of the table. The trick of the table is using the code, special code, Liati, which is logarithm, integration, algebraic, trigonometric, and exponential. So we will decide which one is one of this, and it should be in order to specify which one is stronger to use the table. So since we will not use this, we'll use the table. The table says, here we'll use the integration, and here is the derivative. So here for the u, we will make derivative, and for the v, we'll make integration. It depends on what we will decide about this. This is exponential, which is e, the last letter, and x is algebraic. So definitely x squared is the stronger, and the stronger is u. So u will be our x squared, and the v is e power minus 2x. Now in this table, we will keep making derivative for the x squared, and here we'll keep making integration for e power minus 2x. So here we have x squared, and we have here e minus 2x. And at each step will become plus minus plus minus. So for the first step is plus, second step is minus, third step is plus, fourth step is minus. Let's start doing the integration and derivative. So the derivative of x squared is 2x. The derivative also of 2x is 2. The derivative of 2 is 0. We can't continue from here. So the last step is at the fourth stage. So we don't need to That's the benefit of the table, so we don't keep repeating a lot of times. We know when to stop, and sometimes if it's continuous, it's enough to take 3 instead of doing this equation. And now let's do the integration of the e power minus 2x. First, every time put itself, and then we'll play with the number which is here. First, we should make the integration of this one, so we will use since it's here minus, so we'll use minus 1 over 2, and here again 1 over 2 times 1 over 2, it will give us minus 1 over 4, but since here sorry, it will give us 1 over 4 since it's minus minus, so 1 over 4, and now it will become again negative 1 over 8 since 4 times 2 is 8. And now how to form the equation, the final equation of the integration? We simply multiply this by this, this by this, and this by this. Of course, positive, negative, and negative. So the integration of x squared times e power minus 2x dx will be the first x squared times minus half e minus 2x, and then minus 2x times 1 over 4 e power minus 2x, then plus 2 times minus 1 over 8 e power minus 2x. Here we cannot continue since it's 0. Even if we continue, 0 times the number which will come here, 0. So this is the first question for integration by parts. Now we will solve question number 18. Question number 18 will be also solving by parts. Every time they give us the y and x, we know that it's the steps of doing the separation and then the integration and then find the c when we will substitute the y and x. So first we need to separate. Our separation would be dy equal x plus 2 sine x times dx. Since also we have here the Liati, we know that the algebraic comes before trigonometric, so this will be the u, this will be the dv. So u is equal to x plus 2, and the dv is sine x. Okay, so the v is integration of sine x dx, which is minus cosine x, and the du over dx is equal to 1, so du is equal dx. So let's now substitute the equation that we know, which is u times v minus integration of v times du. Our u is x plus 2, which is multiplied by the v, which is minus cosine x, minus integration of minus cosine x times du, which is dx. And we know that the integration of minus cosine is minus sine. So x plus 2 times, let's take the minus here, so minus cosine x, and the minus minus, which is the integration of minus cosine x, which is minus sine x, so it will become plus sine x plus c. Okay, this is y equal, of course. They gave us y is equal to 2, so y equal to 2, and x is minus x, x is 0 times, sorry, this back should be outside here, cosine of 0 plus sine of 0 plus c. Then c will be equal to 2 plus 2, which is equal to 4. So y is equal to minus x plus 2 times cosine x, cosine x plus sine x plus c, which we found here 4. This is for the second question, which is question 18. Now to the last question for the objective of solving integration by parts, and which is question 19. The same thing, separation, integration, find the c by substituting y and x and find it. Let's do this quickly. dy is equal to 2x ln x times dx. Now let's make integration for both. Y equal the integration for 2x ln x. Now again by parts and also solving the differential equation. So now we are finishing two objectives at the same time, so we don't make another whole part for solving differential equation. So this video is a combination for the objective of integration by parts and solving differential equation. For this question, the u is 2x. The u is ln x, since we use the order of Liati. So the u is ln x, and the du over dx is equal to 1 over x, and the dx is equal to, after we will swap here, du over x, and the dv is 2x, which means v is equal to integration of 2x, which is equal to, adding the power 1, this one, x squared. Now let's substitute the equation of u times v minus integration of v times du. Du is the u is ln x, as we said, times v, which is x squared, minus integration of v, which is x squared, times du. What is u? U is du over x, so it will come only by x. So y equal ln x times x squared minus integration add by 1 power, which is 2 over 2, so x squared over 2 plus c. Y is 3 and x is 1. C will be 3.5. So y is equal to ln x times x squared minus minus x squared over 2 plus 3.5. So this is the last part for integration by parts. For the video of integration by substitution, for the video for the objective of solving differential equation, there will not be video. Why? Because question 19 and also the 18 that we've done previously, and question 20, which is done in the first video for integration by substitution, is the same questions for solving differential equation. The next part, which is part 3, Newton's law of cooling, waiting for you. Moving the second part of the multiple choice, which is integration by parts, since we finished integration by substitution, which is the only question 11. So we use Biati. The algebraic becomes before the trigonometric, so u is equal to x, which means du is equal to dx. And then dv is equal to secant squared x, which means the v, when we take integration, v is equal to tan x dx, of course. So, and the equation is u times v minus integration v du. Here's x, here's tan x, minus integration, what's the v is tan x dx. And then here x times tan x minus, the integration is minus ln of cosine x, absolute value of cosine x, plus c, which means x times tan x plus ln of absolute value of cosine x plus c, which is part B, which is part C.
Another objective, using integration by parts to evaluate the antiderivative. Question 13 from the system-wide quiz paper. The integration of x squared e to the power of negative 2x dx. First, one of the ways to evaluate or to find the integration using simpler methods is to have an exponential function and a trigonometric. We create a table lookalike, such as this, x squared, which is e to the power negative 2. Then we do the derivative, and the derivative, and the derivative until we meet 0. Then we just add them all together, which will end up being the answer negative half x squared e to the power negative 2x minus half x to the power of e negative 2x minus 1 over 4 e to the power x plus c.